Yes, the previous class we had studied about the periods and groups, what are periods and what are groups, and then how many periods and how many groups are there we have studied it. So today let us study little bit regarding the properties of periods as well as groups. Now, to understand about this one, it is easier to remember about one particular, let's say about the properties of the group. So let's say about one particular group. So I have taken hydrogen, helium, sodium, potassium, and the second number is 1, 3, 11. And when we take about the electronic configuration, hydrogen has got one electron, sodium is 1, and this is now this is what is normally begins, and this belongs to the first group. So what does it mean? The group number is equal to the number of shells. So since the valence electrons are 1, as I told you yesterday, since the valence electron in this situation is 1, so it is belonging to the first group. So what is the first characteristic? Group number is equal to the number of valence electrons. Say for example, remember yesterday we have studied about the normal elements. So group number 1, 2, then 13, 14, 15, 16, 17. These are the normal elements. And then 3 to 11, 3 to 12 is a transition element. So transition element is not part of our syllabus. So we are concerned only about the normal elements. Understood? So in that situation, what we say, the number of electrons present in the valence shell or the outermost orbit is equal to its group number. Alright? Now let's take the case of aluminum. Aluminum has got its atomic number 13, so the atomic configuration is 283. So it has got 3 valence electrons. So what can we say that aluminum is present in the third group? Understood clearly. So group number is equal to the number of valence electrons, and that depends on only on the normal elements, not transition elements. See, we are studying only about the normal elements. Okay, the next property. Going from top to bottom, the valence electrons are the same. All these elements are but one as a valence electron. So what can we say? What are groups? Groups are the vertical columns. So going from top to bottom in a group, number of valence electrons remain the same. Number of valence electrons remain the same means the valency is also the same. Because we have studied it, the valency depends upon the number of valence electrons. If the valence electrons are 1, the valency is 1. And if the valence electrons are 7, then also the valency is 1. What is valency? Valency is defined as the number of electrons a neutral atom gain or the neutral atom loses to become stable. Number of electrons a neutral atom gains or loses to become stable. So as far as this case is concerned, lithium has to lose 1 electron to get the stable configuration, sodium has to lose 1, potassium has to lose 1. So losing of these 1 electron will make their valency 1. Now fluorine, chlorine, bromine, they have 7 valence electron, they belong to the 17 group. And so therefore they need 1 electron to complete the octet, so therefore we can say their valency is also 1. So going from top to bottom in a group, the valency remains the same because the number of valence electrons are the same. Alright? Okay, next property. Size of atom. Size of atom means you can understand it. Let's say this is the nucleus. This contains, let's say the case of lithium, it contains 2 shells, A and L shell. So the total area covered by the nucleus plus the electrons of that atom makes the size of atom. The total area covered by the nucleus plus the electrons that are present around it make the size of atom. So sodium, lithium has got 2, 1 electronic constitutive size. Now when we talk about the potassium case, it is having first shell 2 electrons, second shell 8 electrons, the third shell 8 electrons, and the last shell is having 1 electron. So what does that mean? So going from top to bottom, the size of atom is getting increased. Understood it? Size of atom depends upon the total area covered by the nucleus plus the valence electron. If the valence electron means the total number of electrons. So potassium has got 4 shells. K shell has got 2 electrons, L shell is having 8, the next one is having 8, and the valence shell is having 1 electron. So potassium has got 4 shells, and the total area covered by the nucleus plus the 4 valence shell, 4 shells make the size naturally larger. And lithium's case, when you see it, it has got only 2 shells, K and L shells. So size of lithium is smaller, and hydrogen's case is still smaller. So the size of atom going from top to bottom in a group, it increases. Why the size is getting increased? The number of shells are getting increased. Understood? The next one is atomic radii. when the size is getting increased, then naturally it is understood that atomic radius also will change. So going from top to bottom, the size of atom increases, that means the radius of the atom is also getting increased. So atomic radii will also increase from top to bottom. Clear? The next one is metallic character. Metallic character is defined as the ability of a neutral atom to lose electron. Chemically, metallic character is defined as ability of an atom to lose electron. So hydrogen, as far as this one is concerned, as I told you earlier, hydrogen is the only non-metal which is metallic in nature. Physical properties of hydrogen is a non-metal and chemical property is a metal. Leaving of hydrogen. So rest all these things have one electron to be lost. Right? And so the ability of this atom to lose electron keep on increasing. Now lithium has got its valence shell nearer to the nucleus. So the nucleus is exerting the force of attraction to the electrons. Whereas in this case of potassium, it is much farther away. Understood? So ability of an atom to lose electron depends upon the force of attraction exerted by the nucleus to the valence electron. And the force of attraction depends upon the distance between the nucleus and the valence electron. Understood? 9th class we have studied the Newton's law of gravitation. Force is inversely proportional to the square of the distance. The force is inversely proportional to the square of the distance between them. Therefore, what can we say? In this situation, potassium's one valence electron is on the force shell. It is much far away from the nucleus. It is much far away from the nucleus. So the nucleus exerts least force of attraction to the valence electron that will be something. Understood? So potassium has the ability or the tendency to lose electron much faster. Remember, an atom to lose electron which needs energy. An atom to lose electron which requires energy. So potassium has to lose one electron, it needs certain amount of energy. And that energy, since the nucleus is exerting least force of attraction, the energy is very less. So what can we say? Potassium could lose the electron much more easily than lithium. So going from top to bottom, the metallic character increases. And now what about the non-metallic character? Non-metallic character is defined as the ability of an atom to gain electron. So going from top to bottom, now understand this hydrogen. Hydrogen has got one electron, which is much nearer to the nucleus. So hydrogen can attract one more electron. Hydrogen has got one electron in its nucleus and it can attract one more electron. So hydrogen is little bit electronegative. And lithium's case, nucleus is exerting little force of attraction, and potassium's case, attraction exerted on the valence electron is very less. So ability of the nucleus to retain the electron keep on decreasing. So that means what are non-metals? Non-metals are those elements which have the tendency to gain electron, which are electronegative. So when the non-metallic increases from top to bottom, what do we say? Non-metallic character is defined as electronegative character. So electronegative character decreases, non-metallic character decreases. Metallic character increases means electropositive character increases. Remember it. Electropositive character is metallic character and electronegative character is non-metallic character. So going from top to bottom in a group, metallic character increases, that means electropositive nature increases. Non-metallic character decreases means electronegative character decreases. That's why it is understood. Alright? Atomic radii, I told you. Now, ionization potential. This is a new term. We are studied in 9th standard. What is potential energy? Potential energy is defined as energy obtained due to the position. Similarly, ionization. An atom is to be converted into its ion. An atom is to be converted into its ions. That means how you get an ion. Ions are electrically charged atoms. So from a isolated, that means an individual atom which does not have any force of attraction exerted between the two atoms, that is what an isolated gaseous atom from which an electron is to be removed. Understood? An isolated gaseous atom from which an electron is to be removed, for which some energy is needed. And that energy is known as ionization energy. Clear? Ionization energy is defined as a minimum energy required to remove an electron from an isolated gaseous atom. Understood? Because you know that there is intermolecular force, different types of forces are exerted between the atoms. So when this is not, what is ionization energy? Is the energy needed to remove an electron. The energy needed to remove an electron from the neutral gaseous atom. That is what is known as ionization energy. So ionization energy keep on. Now remember we are studying it going from top to bottom. Metallic character increases. Metals are electropositive. That means the nucleus is exerting lesser force of attraction. And when the nucleus exerts lesser force of attraction, then the energy needed to remove the electron is also less. So what can we say? Ionization potential decreases from top to bottom. Understood it clearly? Because now listen, we have got potassium from which an electron is to be removed. It needs energy. And that energy is present on that potassium's nucleus as ionization potential. Ionization potential energy. That is a simple meaning. And in short, we call it as ionization potential. Understood it? So potassium can lose its one electron by gaining very, very less energy. Therefore, ionization potential of potassium is very less. And whereas when we go up to that one hydrogen, the losing a one electron is rather little difficult. So its ionization potential is high. So going from top to bottom in a group, ionization potential decreases. Understood clearly? The next one is one question, that is how does the nature of oxide vary? How does the nature of oxide vary in a group? We have studied it. There are three types of oxides. What are acidic oxides, basic oxides, and neutral oxides? Three types of oxides. Acidic oxides are non-metallic oxides. Basic oxides are metallic oxides. And some oxides which are neither acidic nor basic are known as neutral oxides. And the simplest example of neutral oxide is that of H2O, that is water. Oxide of hydrogen is neutral. We have studied water acids and bases. Understood it? H2O does not change the color of any of indicators, therefore we say it is neutral. So going from top to bottom in a group, metallic character increases. Metallic character increases means metallic oxides are basic oxides. So basic nature of oxide increases and acidic nature of oxide decreases. Understood clearly? These are some of the common properties of groups. Now one question is, an element is present in the second group. What would be the formula of its chloride? An element P is present in the second group. P is in second group means valence electron is 2, and then its valence electron is 2, its valence is 2. And how it would combine with chlorine? P's valence is 2 and chlorine's valence is 1, so the formula of the compound is PCl2. Understood? And what would be the formula of its carbonate? You know that P is valence is 2 and carbonate is CO3 is valence is 2, so the formula of the compound becomes PCO3. Understood? So these are some questions, out of 80 marks, 79 you may be able to answer it, and one question, this type of one, which may or may not, but I expect, suppose like very intelligent student should be able to, and that is why it is asked. So when we know the group number, we can come to know about the valency. And once we know the valency, any type of molecular formula we can make it. First chapters, crisscrossing the valencies, we get the compound. We are studying the first chapter, crisscrossing the valencies. So P present in the second group, that means valence electron is 2. And carbonate CO3 whose valency is 2. So the compound becomes PCO. What would be the formula of its nitrate? P whose valency is 2, nitrate's valency is 1, the formula becomes PNO3 and in this way the formula has been made. And one more question is, since the atomic size increases from top to bottom in a group, they might be giving you 3 A, B, C, D, E, 5 elements are given, and their atomic size or atomic radii will be given. Understood? And the question is, if all these 5 elements are present in a particular group, how would you arrange them in the group? Understood? If all these elements are present in a group, how would you arrange them? And what we are studying, going from top to bottom in a group, size of atom increases. So you write the answers in ascending order of atomic size. Ascending order of size, that would be the arrangement of elements in the groups. Because going from top to bottom, size of atom increases. Clear about these properties of the groups? Remember, valency in a group remains the same because valence electrons are the same. And what would be the formula of the compound which is present in a particular group? So a group number from which you can get the valency, and once the valency is known, we can understand what would be the molecular number. These are simple questions. The periodic classification is very easy and completely scoreable answers. You can answer it. It is very easy. Okay? The next one is that of periods. What are periods? We have studied yesterday, periods are the horizontal columns. Left to right columns are known as periods. Understood it? So to study about the properties of the period, let's take one particular period. And one period is taken, and based on that period, we study the properties. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Arrangement is ready 3, 4, 5, 6, 7, 8, 9, 10. Ascending order of atomic number. Electronic configuration from 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, and 2, 8. So this is what it is. Now, something which is common in these all elements, you can understand it. All these elements are what? Two shells. 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6, 2, 7, 2, 8. So what is the first characteristic? The period number is equal to the number of shells. And so this is which period we are doing it? Second period. Understood it? If you take an element, say for example potassium's atomic number is 19. So 19 means these 2, 8, 8, 1 such as the 4 shells. So potassium is present in the fourth period. Understood? So group number is equal to number of shells, and period number is equal to group number is equal to number of valence electrons, and period number is equal to number of shells. Remember, this is what we are talking is only of the normal elements, and we need to know only about that. So this is in the second period, correct? So if it is asked in which period does aluminum belongs, so you should know the first 20 elements. Aluminum's atomic number is 13, so therefore its electronic configuration goes 2, 8, 3. There are 3 shells, so aluminum is present in the third period. Understood it well? Okay. Now, going from left to right, see the valence electron 1, 2, 3, 4, 5 is increasing. So, what can we say? Why the valency of elements in a period does not remain the same? You understand? This is a simple question. Because going from left to right in a period, number of valence electron increases by 1. Going from left to right in a period, number of valence electron increases by 1. So 1, 2, 3, 4, 5, 6. So, and valency we have studied it, number of electrons and neutral atom gains or loses. Valency is defined as number of electrons and neutral atom gains or loses. So lithium has got 1 electron to be lost, therefore its valency is 1. Beryllium 2, boron 3. Carbon needs 2 because we are studying in carbon compounds. It shares its electron with other carbon atoms, so carbon's valency is 4, nitrogen is 3, oxygen is 2, fluorine is 1. So what has happened? Going from left to right, the valence electron increases by 1, therefore valency varies. And remember the definition of valency, it is the number of electrons a neutral atom gains or loses. So as far as this particular group period is concerned, the valency increases by 1 up to 4. Lithium's valency is 1, beryllium is 2, boron is 3, carbon is 4. Understood it? Nitrogen is 3, therefore it is valency getting changed accordingly. So going from left to right in a period, the valency increases by 1 up to 4 and then decreases. And in group, the valency remains the same. In group, valency remains the same, valence electron remains the same. In a period, valence electron increases by 1 and valency increases by 1 up to 4 and then decreases. Okay? The next one is metallic character. See, you can easily remember this one. What are the properties of groups and periods? Except the valency and valence electron. Except the valence and valence electron, rest of the properties are just opposite that of the period. Like the properties. Now here, let's take this one, metallic character. You know? Metallic character is defined as the ability of an atom to lose electron. Now you can think this lithium has to lose 1, beryllium 2, boron 3, carbon 4. It cannot be acidic, it cannot lose 4 electrons, so it will be sharing, and this needs 3 electrons, this needs 2, this needs 1, and the last one does not need any electron. So what can we say that? The ability of an atom to lose electron, keep on decreasing it, because lithium has to lose 1, which is much easier. Beryllium has to lose 2, which is little more difficult. Boron has to lose 3, it's still difficult more. Understood? So going from left to right, ability of an atom to lose electron keep on decreasing it. Ability of an atom to lose electron keep on decreasing. So it has a tendency to gain the electron. So metallic character decreases from left to right in the period, and if the metallic character is decreased, what can we say that the non-metallic character increases? The same reason. Non-metallic character means ability of the atom to gain electron. Fluorine needs one electron to complete the octet. Understood it? Oxygen needs two electrons. So gaining one is much more easier than gaining two. Isn't it? So from extreme left, the tendency of an element to lose electron, and we end up with the element which has a tendency to gain electron. So left to right, what is taking place? The metallic character decreases and non-metallic character increases. Similarly, along with that, one can be say the ability of its nature of oxide. Nature of oxide, when the metallic oxide, that means basic nature of oxide decreases and acidic nature of oxide increases. Basic nature decreases, acidic nature increases. These are the properties of this one. Now, let's study about size of atom. Size of atom, as I told you in the previous, in the case of group, it is the same. Now, every element of this particular period has got two shells. Understood it? But what has taken place is the nuclear charge is getting increased. Lithium has got 3 positive charge, beryllium 2, boron 3, boron 4. So the nuclear charge is getting increased. Lithium has got exactly what I say, it has got 3 protons, beryllium 4, boron 5, carbon 6. So going from left to right in a period, the nuclear charge gets increased. That means the nucleus is exerting larger force of attraction to the valence electron. And when the electrons are attracted by the nucleus, these electrons tend to come nearer to the nucleus. So what is taking place? Lithium size is larger because nucleus has a lesser force of attraction to the valence electron, and fluorine size is much smaller because fluorine has got 9 positive charge that will be exerting the valence electron nearer. So 9 positive charge is much larger than that of 1 positive charge. So nuclear charge gets increased and the force of attraction will get increased, and which will pull the electrons nearer to the nucleus, understood? Making its size smaller. So going from left to right, the size of atom decreases. And always remember, inert gases are got the orbit complete. Inert gases are got the valence shell is complete, its orbit is full. And when its orbit is full, the force of repulsion is exerted among the electrons. Understood it? And that force of repulsion among the electrons will push the electrons outwards. So that makes the size of neon larger than that of fluorine. We cannot compare it with anything else. I cannot tell you that the size of neon is larger than that of oxygen or lesser than that of some other element. What we can say that its size is larger than that of fluorine immediately, because the halogens have got the smallest size among the period, among that particular period. The halogens are having the smallest size in that particular period. The reason is the halogen, you know that the valence shell has got 7 electrons, orbit is not full. Understood it? And when one more electron is going into that, and that will increase the force of repulsion. And when 7 electrons are there, is enough space for the electrons, and the nucleus could attract them, so electrons will be coming nearer to the nucleus. So the size is smaller. So all the properties of periods are up to the 17th group. 18th group is zero group, we leave it. But remember, the 18 group elements are what? Little larger size than that of the previous element. Because the force of repulsion exerted among the electrons will push it outwards. Remember it. You know that neon is a non-metal according to its physical characteristics. Metals are electropositive, they have the tendency to lose. Non-metals are electronegative, they have the tendency to gain. What about neon? It is neither going to lose nor going to gain any electrons. How we classify them? Understood? So that is it. Then, size of atom I have mentioned it. Ionization potential, because when the metallic character is getting increased, ionization potential is also getting increased. Now, similarly, I asked you the previous one. A, B, C, D, E, F are 5 elements given and their atomic radii are given, and arrange them if they are present in a particular period, arrange them. How would you arrange them? Arrange them in left to right in the descending order. Isn't it? Left to right, the size of atom decreases. So you need to write about in the descending order. That would be the arrangement of elements in the period. And in a group, ascending. Understood clearly? Now, simply a question is given, and atomic number of chlorine is 17. In which part of periodic table would you find chlorine? So how can we say that? Chlorine atomic number is 17, electronic configuration is 287. So it is present on the third period and 17 group. Understood? That's all. So once we know the position of the element, it is being given that an element is present in the second period and second group. What would be its atomic number? Second period means 2 shells. Second group means valence electron is 2. The first shell has got 2 electrons and the second shell is also having 2. So the total number of electrons becomes 4. Therefore, its atomic number is 4. And in this method, we can say about all the properties. Understood? Now, one more question is, which part of periodic table or where in the periodic table will you find the most smaller size atom? And it is not period and groups. It is asked in the periodic table. So which part of the periodic table would you find highest electronegative element or largest size element, most metallic, most non-metallic, etc. In that situation, we will have to understand it on the basis of the properties of groups and periods. Now let's say, where in the periodic table would you find the most metallic element? Left to right, metallic character decreases. So extreme left is a metallic one. And top to bottom, metallic character increases. So what can we say that extreme left bottom element is the most metallic element. Understood? And where would you find the most electronegative element? Most electronegative element means left to right electronegative character increases. So extreme right is the most electronegative. And top to bottom electronegative decreases. So what can we say that extreme right top corner is the element which is most electronegative. Alright. So that's all in that chapter. I discussed many questions. All these things you try and according to the syllabus from the NCERT book, do all the questions. All right.